Design an AI model with deep neural networks for a production planning and control forecasting system. Creating a deep neural network, DNN, for production planning and control forecasting involves several steps. Pradeep K. Suri. Author and researcher. 1. Data collection and pre-processing. Gather historical production data including variables like production rates, resource utilization, demand, inventory levels, etc. Pre-process the data, normalize, scale, handle missing values, and split it into training, validation, and test sets. 2. Define model architecture. Choose the appropriate neural network architecture for forecasting. Recurrent neural networks, RNNs, long short-term memory networks, LSTMs, or gated recurrent units, GRUs, often work well for time series forecasting due to their ability to capture sequential dependencies. Consider the input features, such as time steps, different production factors, and output targets, example future production levels. 3. Model development. Implement the chosen architecture using a deep learning framework like TensorFlow or PyTorch. Train the model on the prepared dataset, adjusting hyperparameters, learning rate, batch size, number of layers, neurons, etc., to optimize performance. Use appropriate loss functions, like mean squared error for regression tasks, and optimization algorithms, example ATOM, RMS prop, to train the model. 4. Model evaluation and validation. Evaluate the model's performance using the validation set, considering metrics like mean absolute error, MAE, root mean squared error, RMSE, etc. Validate the model's ability to generalize by testing it on unseen data from the test set. 5. Fine-tuning and deployment. Fine-tune the model based on validation performance, adjusting hyperparameters, or modifying the architecture as needed. Once satisfied with the performance, deploy the trained model to the production environment. Example code, using Python and TensorFlow. Python. Import TensorFlow STF. From TensorFlow.keras.models import sequential. From TensorFlow.keras.layers import LSTM, dense. Hashtag define and compile the LSTM model. Model equals sequential. Model.add, LSTM, units equals 128, input underscore shape equals time steps, input underscore features. Model.add, dense, units equals 1, hashtag output layer. Model.compile, optimizer equals atom, loss equals mean underscore squared underscore error. Hashtag train the model. Model.fit, train underscore x, train underscore y, epochs equals 50, batch underscore size equals 32, validation underscore data equals val underscore x, val underscore y. Hashtag evaluate the model. Loss equals model.evaluate, test underscore x, test underscore y. Hashtag make predictions. Predictions equals model.predict, test underscore x. Considerations. Feature engineering, incorporate domain knowledge into feature selection and engineering for improved forecasting accuracy. Regularization and dropout, prevent overfitting by using techniques like dropout layers or L2 regularization. Ensemble methods, combine predictions from multiple models or use ensemble methods to enhance forecasting accuracy. Remember, the success of the model heavily depends on data quality, feature selection, model architecture, and hyperparameter tuning. Iterative refinement and continuous monitoring are key in developing an efficient production planning and control forecasting system. Thank you.